Hi, hello.
Hello.
So, hello everyone. Welcome to our webinar on AI-driven data engineering for water metering. My name is Radek and I'm a data scientist and the stream, specializing in leveraging data science and machine learning tools to solve complex business problems. I'm very pleased to introduce Michał, who is joining us today. Hello, Michał.
Hi, Radek. Hi, everyone. I'm Michał. I'm a data engineer with over a decade of experience. Here in the stream, I'm working as an AI and data expert with the focus on the data platform architecture.
Thank you, Michał. And today we are going to discuss a very important topic related to water and data. I mean water metering. So please feel free to ask questions or share your comments or thoughts at any time during the session. After the session, you can chase us on LinkedIn. So stay with us and let's get started. Why water metering matters? Every day, water utilities face many challenges and pitfalls related to their business. Thanks to smart water metering, they can monitor and control their operations at every stage of the water metering process. A common example of a pitfall is unexplained leaks, which often go unnoticed until they cause serious damage. What is more, meter can produce massive amount of data in various formats at different frequencies and stored in very different locations. It can be challenging to bring this data together in a way that presents a complete business picture and enables data-driven decision making. Moreover, faulty meters can produce inaccurate readings, messing our reports and data, either under-reporting or over-reporting, for example, water usage. Next, uncovering, analyzing, and forecasting any changes in water usage behavior over time can help in better planning for future infrastructure investments, saving energy and money, and preparing water utilities for high-stress situations. So that's why it matters. And some time ago, Michał and I participated in a water metering project addressing all these challenges I mentioned before. So, Michał, could you please share a few details on it?
Yes, of course. Thank you for the introduction to the topic, Radek. The project that you've mentioned was for one of the metering companies in Germany, where we collaborated with our customer for the last year. But first of all, maybe let's start with what problems and what challenges we have with the metering data. First of all, let's start with missing data and the gaps in the readings or lack of new readings. Due to the failures of devices or network problems or some delays in gathering of the data, sometimes we do not receive the full data set. And the problems behind that are there are multiple problems that can lead to that, which is one of our biggest struggles, since we need the full data sets to predict leaks and use it in the dashboards. Second of all, the performance tuning of the whole solution can be tricky because devices are for the whole cities, even countries from all over the world, which means hundreds or thousands of them, each gathering multiple types of measurements, such as flow, pressure, or temperature. And so together, it's a big challenge to create a solution that will be performant with so many data points and from multiple devices. Lastly, when we are talking about metering, we are thinking of IoT devices that measure the water. And with IoT devices, the natural solution is the streaming. So to get the near or even real-time dashboards and changes. But this forces us to use data streaming which can be much more troublesome and much more expensive. So for this given example, for this customer, we refer to data in micro batches every hour. Now, let's see how we faced those challenges that I mentioned and how we used the data. First of all, due to the mentioned data problems and that we had to apply techniques like interpolation and extrapolation. Both try to solve the problem of missing readings, and interpolation helps with gaps in older readings when we didn't receive the data from the device for one of the historic periods. Here on the graph is marked in red, so it's the part from history, while extrapolation fills the readings that are missing from last measurement that we received up until to the date of last batch load, here in the graph marked in blue. Those extrapolated readings are later replaced with actual data when it arrives. Sometimes it didn't arrive, but it don't arrive, but when it arrives, it's replacing those extrapolated values. Both techniques use some special statistical models under the hood to fill all those measurements, and they were prepared with collaboration of our customer.
Yeah, and I remember that also we created and introduced to the production leak detection machine learning models. So having data, having curated data and validated data, and working very closely with subject business matters, we define precisely what the model should do, what the problem should be fixed, and trained and created on many IoT data machine learning models related to neural networks, but with very decent accuracy. And as a result, it had been pushed to the production and working every hour, I believe, in every be followed by batches. Yep.
You're right, every hour, yes. And on top of the machine learning models, we also had, let's say, this standard advanced dashboard that presented all necessary KPIs for end users, as well as the whole maps of the networks. And since we received from the devices their location, which also looked great. Now, let's switch to more technical part, where I want to explain you how we've created the whole data platform and what technologies we've used. First of all, we leverage Databricks as a platform for our project, and we used the catalog for both data engineering and task, as well as keeping machine learning models there. And machine learning models has this mentioned leak detection one and all future ones that will be there. Unity Catalog gave us ease of deployment, great development, and maintenance of machine learning models, as well as the pipelines. We also used industry's best practices, such as keeping everything as code. And by everything, I mean really everything. So data pipelines, infrastructure in Terraform, the training for code for machine learning, as well as even the documentation. Everything was there in the repository. Why we did that? Because this enables easy automatic deployments which leads obviously to less mistakes and the whole data platform outages. Keeping everything as a code also leads to easier introduction of agentic AI, but this we will cover in the next slide.
Yeah, agentic AI. Michał, a phrase, agentic AI, has been recently becoming extremely popular. And I'm wondering if it's only a buzzword, we have a lot, or it's a powerful tool that can support our client's business. What do you think?
Yes, you're right. Agentic AI is not only a future; it's happening right now and can help us a lot. First of all, let's recall those problems with the data gaps, the ingestion from the IoT devices. When some problems occur, like for example, the pipeline will fail after the file sent from the device, let's say, has new column in it that we didn't expect, or expected column is missing. The pipeline will error out, and specially created agent can immediately investigate what went wrong, try to fix the code, create the pull request to the repository for engineer to review. This makes fixing of the errors much faster, and we also we also use those good practices with the automation and everything as a code. The fix can be deployed to production in a matter of seconds, maybe minutes, but yeah, actually really fast. What I also want to highlight here is that by the end of the fix, by the end of the work of the agentic AI, and there is also there is always an engineer that is reviewing the code and checking the changes, so that we are safe with the solution that we want to deploy. The same approach can be also applied to the errors in transformation. So same pattern. If we have a problem, then then agent can fix it and create a pull request. What I also want to mention is that for our customer, we've created a special framework that simplified the development process for engineers, because it handled such tiresome things like handling of the metadata, handling of the watermarks, defining schemas for the new tables on writes, or logging. And using this framework, data engineers could focus only on delivering business values to end users. Why I mention it here? Because this can also help with generating the whole transformation code by agents, since, as we know, AI is the best at simpler tasks. So the fact that it can use this framework and only focus on the contents of the transformations helps with creating better product. Lastly, I also mentioned here the documentation generation. Since using AI, we can create this detailed documentation of the whole logic in the code, and as we know, no one likes to write documentation. So it makes our work easier. Those are only 4 examples of agentic AI usage that we can use right now, but taking into account that we are in the fast developing AI era, the sky is the limit here.
Yeah, so now I see that agentic AI is not only a buzzword, but it's a really powerful tools. Thank you, Michał. Thank you for a great discussion, for a presentation. And as a host, maybe before we go to Q&A section, I just want to mention that in DS Stream, we know how smart metering is important and how to apply AI tools, agentic AI, machine learning, data science to solve metering problems, to improve metering business. So I don't see any questions.
Yeah, for now, no questions
so far.
People are here. Hello, everyone.
Hello. I'm very happy that you are with us, to spend this time with us. Topic is extremely interesting and important, especially because there is a small amount of potable water. And yeah, we have a first question. Great. Is AI really that much better than regular water meters when it comes to finding leaks?
Yeah, I think I can answer that. With the machine learning model that we've created together with our customer, can predict leaks properly and with great accuracy. So without this model, so without the AI, we cannot be sure whether lack of the data from the device is a problem with the data gathering or actual leak. So machine learning or AI is great use here, and yeah, it's so the answer to sum up is yes. It's really much better than just regularly checking whether the data is there or not.
Yeah, I would add that we are using machine learning and other advanced statistical tools in order to uncover very complex pattern, to predict things, to forecast, or to just be well informed. Thank you for the question. Oh, we have the next one. Can cities usually actually use these AI predictions for like real planning, or it's more theory for now? This is a very interesting question. Let me take it. Not only companies, on one hand, companies, on the other hand, cities and other organizations collecting a lot of data, massive amounts of data. And this data started to be analyzed. So yes, for planning, for optimizing costs and processes, for monitoring, for at least controlling, every organization, including cities, of course, can use AI models, can use AI solutions and tools to improve their business, improve their everyday work. I think so.
Yeah, you're right.
Thank you. Do we have more questions?
Not have more questions then.
If there is no more questions, I would like to thank you for staying with us. Thank you, Michał, for a presentation and a great discussion. Chase us on LinkedIn. We'll be very happy to answer your questions, and stay tuned. Bye-bye.
Yeah, thank you. Bye.